students, welcome back to my channel Learning Made Simple, and I am your physics lecturer Srimati Sujata. Hope everyone is doing good, learning physics, studying physics, practicing physics at home. So today I am going to deal with another topic of the same chapter, electric charges and fields. Yes, I am doing still the same chapter, yet I have to complete 10 videos on this. So very small topics are there which I am going to cover. Definitely you will get 1 mark questions from this small topics, and even we are using these small topics for learning the laws, Gauss law or dipole and all we require there. So hence these are must and should we have to cover. So here another such topic is distribution of charges, okay, or you can say continuous distribution of charge anta helbodu. See, up till now we were considering charge as a point charge. Means if it is sitting at one place, okay, if it is concentrated at one place, if a charge is kept at one place, then that was called as point charge. Yes, the size was very small and we were taking it to be as a point charge. Now what we are going to do is we are considering the charge is distributed all over the surface of any body. If you place a bunch of or handful of charges on any of the sheet, right? If you spread those charges, what happens? Those all charges will spread and accumulate certain position in that sheet. Okay, so this was the distribution of charge. So according to the shape, depending on the shape, we started to give different names for distribution of charge. Okay, so what is distribution of charge? Charges are distributed all over the surface of the given shape body. Okay, any shape of body it might be, but here we are considering only 3 kinds of shape. Linear shape, the area we are considering, linear means just like a thin wire, okay, or this pen, you can take a thin wire or this pen, right? So straight line, okay, so that is linear distribution. Areal means if you consider any surface, a square or a rectangle or any square shape or rectangle shaped body which has a surface area, okay, right? So that is called as areal distribution. And the third one we are considering volume distribution, volumetric distribution we can say. What is volumetric distribution, by the way? If you consider a 3D picture or 3D body, like if you consider cube or cuboid or cylinder, okay, if you fill that cylinder or if you fill that cube with the charges, then it occupies entire volume of that body, right? So that is called as volumetric distribution. So we'll study one by one. So what is distribution of charge, by the way? Charge get distributed. So up till now we were considering charges are discrete, okay, q1, q2, q3. This was the thing we were calculating. We were we were considering. Why we were considering them as a discrete charges? Because to do our calculation very simple, mathematical calculations very simple, so that we can apply the algebraic rules at once and we can calculate them. Okay, now instead of that, if you consider a continuous distribution of charges, continuous distribution of charges means one after the other, okay, so bunch of charges we can say, a handful of charges we can say, right, one after the other, okay. So such charges we call it as continuation distribution of charges. So continuation distribution of charges, to calculate, here we are going to use calculus. Okay, again the mathematical tool what we are using here is calculus to find it. Okay, so calculus becomes very difficult to use, hence we were doing, we were considering all the charges as a discrete, q1, q2 and q3 and so on we were using. Okay, so here after knowing distribution of charge, again what we have to do, you have to find the electric field due to those different type of distribution. Okay, so we'll start with this. I hope you understood the introduction part of this distribution of charges. So let's not waste the time, let us start distribution of charges. So depending upon the shape of a body, charges are distributed, and based on that we are giving the names. So the first one is linear distribution of charge. So how the charges are? Charges are continuous. They are not discrete right now. They are continuous. Okay, linear, areal distribution of charge, and volumetric distribution of charge. Okay, so we'll start one by one. What is linear, areal, volumetric? So linear distribution of charge. Linear distribution. I'll just write linear distribution. Okay. So what is linear distribution? So linear distribution means when a charge is evenly distributed over the length. I told you linear distribution means if you consider any of the straight wire, I'll just draw it here. I'll use this pen, red pen, right? So if this is the straight wire you're considering, okay, linear wire, straight wire, right? Wire, and we have brought a handful of charges and we have thrown on this. Okay, we have thrown on this. Then what happens? All the charges will accumulate here continuously, one after the other on this wire. Okay, they go and settle on this wire. Remember, all the charges will settle or distribute evenly only on the surface of the body. They will not enter into the body. Okay, they won't get inside the body. Instead, what they do, they always distributed over on the surface of the body. This point you remember. Why there is a reason for it. I'll explain it in the second chapter, right? So this is the wire I have considered here, having certain length. Say I'll consider the length of this as small l. Okay, you can take capital L, anything as such. Okay, capital L, small l I have taken. Now, so how the charges are? They are distributed like this on the surface, right? On the surface they are distributed, or else here also you can show. So evenly they are distributed over the length of the wire. So this is called as linear distribution, or I can show it by drawing what? By drawing electric field lines. Suppose I consider some point here, so I can draw the electric field lines like this, right? See, this is how you can draw. I hope you are imagining this. Here one, here one, here one, and similarly everywhere. Okay, this field lines indicates what? Charges are present over there. Okay, so this is linear distribution. What is linear distribution? When a charge is evenly distributed over a length. So for this such type of distribution, we are using a quantity. Called as linear charge density. Linear charge density. So what do you mean by linear charge density? Linear charge density means density of charge. Okay, how? In the linear manner, in a straight line manner, means more dense charges in a linear manner. Okay, so that quantity is been denoted by a symbol lambda. Okay, lambda. This lambda indicates what here? Linear charge density. So how we are defining linear charge density now? For this, considering definition for this, we have to consider, say, a small length element here. This is the length element I am considering. Length element means the small part of length element, a small part of length of this entire wire. We are not considering entire length because it might be infinite also. So what we are going to do, instead of considering entire length, so here we are considering small part of this. So small part of that, I'll take it as delta L. Okay, so how many charges might be present in the small length? this one, count it. So after counting, I got the value delta Q. Okay, so the ratio of this charge per length, you can say charge per length. How you are writing in sentence? Charge per unit length, you can say, or just you can say length. So what is the formula used here? Delta Q by delta L. So this formula I am going to use to find electric field due to a continuous charge distribution. Okay, so what might be the SI unit of lambda? SI unit of lambda. So what is it? So it's coulomb per meter. C by L, coulomb per meter. So I hope you understood linear distribution. Now I'll calculate the electric field due to a linear distribution. So this side I am going to do. So what I'm going to do now, let us find now electric field due to what? Due to continuous charge distribution. Charge distribution where, or continuous charge distribution ಅನ್ಬೋದು ಅಥವಾ just you can write linear distribution. So for this what you have to do, again you have to consider this length. Here I'll draw once more. So say assume this is the small wire I have taken, not small, it is infinitely long. I'll show it. So this is the dotted line indicates it's infinitely long. Okay, so this is charge now. Where are the charges present? Here, linear evenly distribution of charges there, continuous distribution of charges there. So let us assume the length of this charge as small l. Okay, so what I told you, we cannot take entire length of this wire. So instead of what we are going to do here, we are going to take a small element of this length. Small element of this length means the part of that wire. Okay, so this part of this wire here, I'm shading it so that you can make it out. So I'll name it as DL, right? DL, or you can take delta L, doesn't matter. So due to this small delta L, we have to find what now? Electric field. Okay, so how many charges might be present here? So here, if suppose Q charges are present, small q I'll take. So these all number of charges, if I take it as Q, then in the small length element, what might be the charges? dq. Okay, dq. See, don't misunderstand if I'm writing here d means it's a change in the quantity, like you're using in differentiation, right? It's not differentiation here. What here, instead of that we have taken small element, small charge. Okay, dq means small charge, that's it. So due to this length element, at somewhere point P, you can take somewhere here or here, anywhere. I have taken here. Okay, so the distance between the point P and this length element, I'll mark it as R. At this point P, what we have to do? We have to calculate electric field. Okay, due to this entire length, first what you're going to do, you're going to find the electric field due to this small length element dl. Then you're going to integrate it for entire length. Okay, shall we start? So very simple, the explanation what I have given, I hope you understood. If not, pause the video, rewind it and listen. Okay, so all this masala I am not going to write it. It will be provided in the notes, you can see it and write. But here you understand the concept very clearly. So now, what is the charge on DL? Charge on this DL, dq, correct? Can you give dq value? Yes, definitely. By using this expression, delta q is equals to what? Lambda into delta L. Since your charges are distribution is linear, so that means which quantity we are using here to define? Lambda. So that means here linear charge density is there. So therefore dq is equals to Can I write lambda into dl? I hope you are understanding this. Clear? So this is number of charges present where? In dl. Now, can you calculate dE? What is dE? This is the electric field, small electric field produced by whom? Produced by dl. This is what E, what I have mentioned here, it's a total electric field, okay, due to entire length, L length of the wire. Okay, first I told you, no, in physics, if the complex things are there, then what we have to do? We have to divide them into small fragments, small elements, and due to that small element, whatever you want, force, field, anything you can calculate, and the same what you're going to do, integrate it for an entire length. So same thing in PUC first year we have done for work done. Okay, dW work was calculated, and we used to do for entire time or something used to take. So integration of dW used to do, right? So same way here it is. Okay, if not remembering, you can go and check over there. I have explained about the integration, everything, first year. Okay, now can we write 1 by 4 pi epsilon into, what is the expression here? dq by r square. dq by distance between dl and p is r, so r square. What is the charge due to dl? dq. Okay, what is dq? Lambda into 1 by 4 pi epsilon naught. So in place of dq, can I write lambda dot l by r square? Clear? So this is what? This is the electric field due to small element. Which element? Length element. I'll write here. Length element dl. I told you, now we have to find it for entire length. Right? So to find entire length, what you have to do? Integrate. Integration of what? Integration of dE. Integration of dE. So that I'll do here in the next page. So integrating this equation, integration on both the side. Here over y I have written here L, it indicates it's over entire length. So what is the entire length of that wire? It is small l. Here no. This is separate quantity, this is separate. Okay. So integration of dE, what do you get? E. Okay. Now 1 by 4 pi epsilon naught, it's a constant. So I have told you the rules of integration. You have to write outside the integration symbol. So here integration for L, lambda into dl by r square. So this is the final expression. What is here? It is the total electric field due to the entire length of the wire, right? Entire wire, right? I hope you understood. So you have to remember this final expression. It might be asked for 1 marks. Okay, so just mention the expression. Okay, so but here I have derived it in very small way, smaller steps I have made, and I have derived it. Okay, so now further, if you understood this derivation in a very simple way, then it becomes very easy to understand areal distribution. So now second type of distribution is areal distribution. So we'll study areal distribution. So areal distribution means, I hope in the name itself you can just guess the definition of it. If the charges are evenly distributed over a surface area, okay, if it might be circle shape or a square or a rectangular shape, okay, if you take a handful of charges and if you throw on that area or surface area on that geometric figure, then the charges distribute evenly over that surface. So for example, I have considered here a rectangular shape, and I have placed it in this way. Okay, in this way I have placed. How? Perpendicular to the surface, perpendicular to the floor. Okay, so here I have thrown a handful of charges over it, so the charges gets distributed in this way. It completely covers it, so I can't draw all those charges, and it takes much time of yours and even mine. Okay, so that is been shown by what? Electric field lines. So the presence of electric field lines indicates what? There is a electric field. So these are the electric field lines due to this shape. Okay, so these electric field lines indicates what? That there is a electric field, right? There is a, that this body is charged, right? So this is areal distribution. If charges are distributed areally, if charges are distributed evenly through the surface area, then that is called as areal distribution. So in such cases, we are going to use the quantity as as was where we are used for linear distribution. Same, we are using here another quantity. We call this quantity as surface charge density. Surface charge density means what? Density of charges over the surface, number of charges over the area. Okay, so how it is denoted by a notion called as sigma. I can read it as sigma. So sigma is equals to delta Q by delta S you can take, or you can take delta A. If suppose I measure this surface as S, total surface area of this as S, then if I consider a small portion of this, I told you in physics always the complex things are being divided into small parts, and that small parts we are considering, and for that, for small part we are calculating either force or field, and the same thing is done for entire portion, right? So here similarly I have considered a small portion of this entire surface, so I'll name it as delta S. Okay, and the charge present over here means delta Q. So charge over here delta Q, right? So that's what. Therefore, what is the sigma here? What is surface charge density of this? Sigma is equals to delta Q by delta S. Okay, so you can just write the definition also. Charge per area. Okay, charge per area is called as surface charge density. So then its SI unit is coulomb, meter is to minus 2. Coulomb per area means C, meter is to minus 2. Okay, so this is areal distribution. Now we will find electric field due to this surface. Say areal. So we will find now electric field due to areal distribution of charges. For that I have considered the same diagram having surface S. In that surface I have taken a small surface area, and that small surface area we will mention it as delta S. So how many charges are present here? Delta Q. Okay, now due to this small surface delta S, we have to calculate what? Electric field. At where? At any point. I'll consider point here. Okay, so we'll find the electric field due to delta S. Then what might be the distance we are taking here? R, as usual. So what is the number of charges present over here? Here I'll take small q, sorry, small q. Okay, it's small q. So now we'll find small q. Therefore charges on this delta S, charge on delta S, small element. What is delta S? Area element. Okay, what is delta S? Area element. So can you find delta Q? So delta Q is equals to, what is sigma? Sigma here in this case delta Q by delta S. Therefore delta S is equals to what? Sigma into delta S, right? So now what is the electric field due to this small surface area? Electric field due to this small surface area will be very small. So we are mentioning small things by dE. So dE is equals to 1 by 4 pi epsilon naught into charge here. What is the charge? Delta Q charge divided by what? What is the distance between point P and delta S? It is R square. Okay, now this is the delta Q substitution we will do. So dE is equals to 1 by 4 pi epsilon naught into sigma into delta S by R square. Okay, so this is what electric field due to a small area element. Okay, if you want to mention area element. Okay, electric field due to area element delta S. Now what we have to do, we have to find total electric field, right? Total electric field means what? Electric field due to this entire surface S. So for that what we have to do? Integration, right? So this is one of the thing we are using, tool. Integration of delta E is equals to integration of this 1 by 4 pi epsilon naught into sigma into delta S by R square. Entire surface means here notation will be yes. So delta dE can be just written as E integration of S 1 by 4 pi epsilon naught. You will take outside the integration symbol because it is constant. So what is left out? Sigma into delta S by R square. Okay, so this is the final expression for electric field due to areal distribution. So now we'll see another type of distribution, volumetric distribution. So what is volumetric distribution? If charges are evenly distributed throughout the body having certain volume, means it is filled with that charges. I said you, if you have a cube, okay, so cube, so if you take a handful of charges and if you throw on that, so what happens? All the charges go and settle on that, right? So remember, the charges always covers what? Surface, not inside the body. Okay, so here the charges are distributed throughout the body having certain volume V, and that is called as volumetric distribution. So in this case, again we are using here quantity to measure, means that describes what? Volumetric distribution. So that quantity is nothing but volume charge density. Volume charge density. Okay, sigma, rho. We are using a symbol rho. So what is this? Charges filled throughout that body having volume. Okay, that is called as volume charge density. Okay, or what you can say, charges per unit volume. Charges per unit volume. So how I can give it? Sigma is equals to how many charges? Delta Q divided by delta V. Okay, for example, if we have a sphere, here sphere you can take, or any shapeless body you can take. You can take sphere. If I draw sphere, it looks like circle itself. So what I do, I take any body. So this is a 3-dimensional, remember. So now 3-dimensional. So here you are taken small part of it, and how many charges are present here? Delta Q. I'll take here capital Q, you can take, or small q, capital Q. Here delta V is the volume, capital Q. Okay, so this is what? Delta Q by delta V gives you what? Rho. Okay, now what is the SI unit of this? SI unit is coulomb meter cube. Okay, so now what you are going to do now? Next, electric field due to, so now what you are going to calculate? Electric field due to a volumetric distribution of charges. For this I have considered, this is 3-dimensional. Okay, in that 3-dimensional body I have considered small volume delta V. So how many charges are present here? Small q I'll take, delta Q. This pen is not writing. Okay, delta Q. Okay, so due to this small volume at anywhere outside this point P, distance between this and this is, I'll take it as R. So at point P we have to find electric field due to this small element, volume element, right? So same, whatever you are done, same thing again. Charge on volume element you have to calculate. So volume element, charge on volume element delta Q is equals to rho into delta V. And then what is the electric field? Small dE, how you are writing? 1 by 4 pi epsilon naught into delta Q by, here I'll write directly, now you have understood I hope, divided by what is the distance? R square. Okay, now due to integration, okay, integration, what you're going to do, you're going to find electric field due to this entire surface. So directly shall I write 1 by 4 pi epsilon naught entire volume. So this subscriptions you have to write here. So what is it here? Rho into delta V by R square. So this is the expression for electric field due to a volumetric distribution of charge, continuous distribution of charge. So I hope you understood this topic. This is a very simple topic. Okay. So practice these equations, electric field equations for all distributions, so that they may be asked for 1 marks or 2 marks. Okay, so definitely I'm sure about it, they are going to ask it for either 2 or 1, not for 3 or something like that. So if they are asking for 2, this much is enough. Okay, so thank you.